In this lesson, you are going to learn about the Pythagorean Theorem, what it is, and how to apply it to find the missing side length of a right triangle. So let's get started. The things we need to know before we know about the Pythagorean Theorem, there's a few words, few definitions we need to understand. Number one is the hypotenuse. The hypotenuse is a side of the right triangle opposite of the right angle. It is also the longest of the three sides in any triangle at all. So here is a little example, and you do have to have all this written down, so you can pause this if you need time to write all these down. Here is a picture showing you where the hypotenuse is, and you can see it is across from the right angle, and it is the longest side of all three sides of that triangle. Okay, next are the legs. Notice legs is plural, there's two, right? There's two legs in every single right triangle. The legs are the two sides of the right triangle that come together to make the right angle. So you can see that this side and this side right here are my legs of this right triangle, and together they have made the right angle. And those are the three sides of any right triangle. Now, our Pythagorean theorem. Okay, it's fun to say. Pythagorean, right? Fun, yes. So we write the Pythagorean theorem, a squared plus b squared equals c squared. That is the Pythagorean theorem. Now I color-coded these to hopefully help you out, where a and b are the legs of a right triangle. Right? So I did legs in green. A and B will represent the legs, the lengths of the legs. And C will represent the length of the hypotenuse in a right triangle. All right, so let's show you how to use this. We're going to solve for the missing side, C in this case. These are my legs because together they make the right angle. So these are going to be A and B. A and B, it does not matter which one you pick for A and which one you pick for B. It does not matter. So we are going to substitute these values in for A and B. So first I'm going to write my Pythagorean theorem. A squared plus B squared equals C squared. I see that I'm trying to solve for my hypotenuse, so I'm going to highlight C. That's what I'm trying to solve for. Now I'm going to substitute the legs in for A and B. So I'm going to substitute 3 in for A. So it's 3 squared plus 4 squared equals c squared. Because I'm trying to solve for the hypotenuse, I need to solve for c. So now I solve for this equation. 3 squared is 9, 4 squared is 16. Combine my like terms, right? 9 plus 16 is 25. Now I need to solve for c. I need to undo this squared, c squared. I need to undo the squared. The inverse operation of squaring, which we learned about in chapter 2, is square rooting. What you do to one side of the equation, we also have to do to the other. Now, when I square root something squared, I'm left with the base. Now, before when we square rooted equations, we had two answers, a positive one and a negative one. This time, we're only going to get one answer because we are dealing with the length of a side of a triangle. Length is always positive, so we're only going to get the positive number here, so C equals 5. And there's all my steps for solving. So let's try this one again. So this side right here that I'm trying to solve is the hypotenuse, because I know that it's opposite of my right angle, and it looks like it's the longest of all the other three sides. So I'm going to first write the Pythagorean theorem, squared. Now I'm going to substitute values in for A and B because I have the legs. So I'm going to do A squared plus B squared equals C squared. Now if you put 24 in for A and 7 in for B, you're still going to get the same answer. That is okay. So now I'm going to square these numbers. And then I'm going to combine my like terms. And now to undo something squared, the inverse operation is to square root what I do to the right, I also do to the left, and my hypotenuse equals 25. Here we go again. Trying to find C. It's opposite the right angle. Okay? So the hypotenuse is always going to be our C. So let's write the Pythagorean theorem. Got to see that for every single one of these. Now I substitute values in. So here, let's do it the other way. We'll put the largest value in for A, the smaller value in for B, to show you that you still get the same answer. So 12 squared is 144. 5 squared is 25. Add these together, 169 equals C squared. Now I need to square root, because that is the inverse of squaring. And my hypotenuse is 13 centimeters long. What is the length of the hypotenuse of a right triangle? Ooh. So I see no picture, but in my directions it says first, draw a picture. So let's draw a picture of a right triangle with leg lengths of 9 inches and 40 inches. Okay? We want to find the length of the hypotenuse, which is this side, because here's my right angle. Opposite my right angle is my hypotenuse. So I'm going to do A squared plus B squared equals C squared. Oh, I forgot to. Every time we should write that. There's our Pythagorean theorem. Substitute the values in. I see that I am solving for the hypotenuse, which is always C. So I have 1600 plus 81 equals x squared. Now I combine my like terms. So I get 1681 equals x squared. The inverse operation of squaring is to square root. What I do to the right, I do to the left, and I see that my hypotenuse will equal 41. Here we go. Here is the dimensions of a professional baseball diamond or field. It's called a diamond. If we look here, we have a right angle and we have a right triangle where I have 2 legs and then there's my hypotenuse. And we are trying to find the distance from home plate to second base. Well, here's home plate, here's second base, so we're trying to find this distance right here. Well, I can set up the Pythagorean theorem because I have a right triangle shown. Now I substitute my values. Okay? It says to the nearest tenth, so we are going to be doing some rounding here. So 90 squared is 8100. And when you add these together, 16,200 equals C squared. You could have used X if you wanted to. I'm just keeping with C because I know that's my hypotenuse. To undo something squared, we have to square root because the inverse operation of squaring is square rooting. So my hypotenuse, and it said to the nearest tenth, so I'm going to write to the hundredth. This is above a 5, so that rounds this to a 3. I should say that's above a 4. So to the nearest tenth, my hypotenuse is approximately 127.3 feet. Solve for the missing side again to the nearest tenth. The missing side that we have is our hypotenuse because it is across the right angle. So I'm going to use the Pythagorean theorem because I have side lengths of a right triangle. We only use the Pythagorean theorem when we have side lengths of a right triangle. So I'm going to substitute my values in for A and B, and then substitute X in for C. 121 plus 36 is X squared. 7 equals x squared. Now, when the inverse operation of squaring is to square root, what you do to the right, you must do to the left. And x is about, or approximately, now we said to the nearest tenth, since that is 2, that means this stays at 12.5. Here we go. So let's pretend this number is not here. So we want to find the slant height. This side right here is called the slant height of a pyramid. You know the height of the pyramid because you're given right here. But we want to know this right there. We don't know this side. We know this side is 300 or 230.35. So if you look, the height comes down and stops at the very middle of the triangle. To go from the middle to the edge, that's exactly half the length. So what we have to do is we take the length, cut it in half, and that's going to equal 115.175. So that is how we find what we need for this right triangle, because we need to find this right triangle, and the slant height will always, always, always be our hypotenuse. So a squared plus b squared equals c squared. So I'm showing all my steps. Here I have the Pythagorean theorem. Now let's substitute the side lengths, or the leg lengths, of this triangle into my Pythagorean theorem. And this slanted L right there, that stands for slant height. So now let's square these. 2, 1, 5, 2, 3. Now let's combine our like terms. And I get this big long number. Now I need to do the inverse operation of squaring to get the slant height all by itself. What I do to one side, I have to do to the other. And I'm going to go to the nearest tenth here. So I look at the number after the tenth, which tells me to keep this the same because it is below 5. So my slant height is 186.5 to the nearest tenth. All right, again, we have the height. We do not have this side. We're trying to find the slant height. So we need to look at this number. And since the height stops in the very middle of the base of a pyramid, that means that this leg of a right triangle is going to be exactly half of that number, which is 9.1. So this leg is 9.1. So let's write our Pythagorean theorem. And we are trying to find the side opposite the right angle, which is our slant height, which is also the hypotenuse. And now substitute these values in for A and for B. So I substituted the legs in. This gives me 82.81. This gives me 174.24. Combine my like terms, 257.05 equals L squared. Now do the inverse operation of squaring, which is to square root. And I'm going to round to the nearest tenth. So my slant height is approximately 16.03. which to the nearest tenth would just be 16.0 or just 16. And that's the Pythagorean theorem.